Hello, everyone. Today I'll be briefly introducing our work, large language models for spatial trajectory patterns mining. Human trajectory data are typically semantic spatial temporal trajectory data. It is usually represented as a sequence of timely ordered locations, which is the spatial temporal information. Besides, each location can also be associated with a semantic label, like the type of a place of the interest or trip purpose. Jointly considering this information is key for identifying outlier behavior critical to a lot of domain applications, such as infectious disease monitoring or elderly behaviors tracking. Since the human trajectory data is formalized as a sequence of visited locations with enriched textual information, we can easily represent them as a textual description. Here we give two examples here. The first user first go to his working place at Manhattan at an early time, and then go to the restaurant at the dinner time, and then go back to his place at the evening. And second user also go to the workplace at a pretty early time, and then go to the restaurant at a very late time, and then go back. We can then formalize their trajectories as textual descriptors and serve as the input prompt for the large language models. Then we can directly ask the large language models to perform a varied tasks such as anomaly detection, classification, and the similarity patterns matching. Although large language models has already been proved that they can achieve significantly good performance in NLP domain, our question here is, can they achieve good performance in human trajectory domain? A key question here is why adopting large language models to do this task, since we already have many domain-specific models, and they already can achieve pretty good performance. The first point here is that large language models can perform the task in a zero-shot manner, which means there is no requirement for the training data. This is especially valuable because the real data and the labels are extremely hard to obtain for human trajectory data. Second, due to the strong reasoning ability of large language models, it can provide strong semantic meaning level analysis directly. For example, it can be pretty hard for a traditional spatial temporal model to mine such an anomaly behavior that a user visits a restaurant at 4 a.m., which is typically an unusual time to visit a restaurant. But this can be an easy task for large language models. Finally, it is also valuable that large language models can provide human understandable explanations to their prediction results, which are also hard to obtain for traditional models. Now we state our research questions for this paper. We first studied, can large language models effectively detect anomalous behaviors within human mobility patterns? By testing its performance on human trajectory dataset to compare with a lot of specialized spatial temporal models, it is also worth noting that this comparison is actually not even fair for large language models, because the traditional models do require a training process on the data from the same domain, where large language models do not require that and performed in a purely zero-shot manner. Second, we further test whether providing indicative clues about the anomaly can enhance the detection performance of large language models. For example, the types of anomaly behaviors. Finally, we study, can large language models provide reasonable explanation to their judgments? Here we give examples of our used prompts for different types of evaluations. On the top, is the prompt that we only input one user's trajectory into the LLMs and ask it to give the prediction directly. In the middle is the case we give hint about when the anomaly behavior happens to large language models. In the bottom, we simultaneously input several users' trajectories into LLMs, allowing it to compare between different users' behavior for a more comprehensive evaluation. Here is our description of the dataset. We use the patterns of life, which includes 1,000 users and 90 anomaly users, and also the geo-life data, which consists of 69 users and 20 anomaly users. Here we are showing the results of both large language models and the comparison measures. That for the GPT 3.5 and GPT-4, we use the separate prompt. And for the Cloud 2 LLM, we use the combined prompt due to its long context window size. We can observe that even without any hint, that large language models can already effectively detect anomaly behaviors with compared to the traditional spatial temporal models. And by providing some additional indicative information can further enhance the detection performance of large language models. That it is worth noting that the Cloud 2 with hint model already achieved the best performance among all the models here. Here we also give an example of the provided explanations from large language models. That we can observe that large language models can first provide analysis of the normal patterns and then describe the change of pattern and give the evidence that a suddenly increased travel distance and finally present its anomalous score. Here we go to our conclusion. We first demonstrate that LLMs can effectively detect anomalous behavior from human mobility trajectories. Second, LLMs can provide valuable explanations for their anomaly judgments. For future works, we can also consider other spatial temporal tasks, such as classification or similarity pattern matching. And also, we could test for other open source LLM performance. It is also worth noting that how to handle long trajectories due to the limited large language models context window size can be very valuable. Thank you for listening. For more information, please refer to our paper for more details. And I welcome any kind of questions.